So let's see the 22nd question. A sound wave passes through air. The diagram shows the positions of the molecules of the air at one instant. So you can see the sound wave is a longitudinal wave where compressions and rarefactions happen, where the particles are accumulated at one place, that's called compression, and where the particles are far from each other is called rarefaction. So the wavelength in this case is defined as the distance between two consecutive compressions or rarefactions. So what are the compression here? P is a compression, R is a compression. What are the rarefactions? Q is a rarefaction, S is a rarefaction. Another one is also there. If you name here something A, that is a rarefaction. If you name here B, that is a compression. Okay. Now, there are so many compressions and rarefactions along the wave, along the path of the wave. So which distance is equal to the wavelength of the wave? So the answer should be either P to R or Q to S, because P to R is also wavelength, Q to S is also wavelength, because the distance between any two consecutive wave fronts, consecutive compressions or consecutive rarefactions. So PQ, no. PS, no. QR, no. QS, yes. So QS is the answer. Okay. And then 23rd one. The top row of bars represents a set of particles inside the earth and at rest. The lower row represents the same particles at one instant as a longitudinal wave passes from left to right through the earth. So the upper row is particles when there was no wave. The lower set of particles is when the wave is passing through them. Now you see what should be measured to determine the amplitude of the oscillations of the particles in the lower row as the wave passes. So you need to know the amplitude from this one. What is amplitude? Of course, imagine the particle is here. The maximum distance that it moves in any direction is called amplitude. So how much distance it moves from its mean position is called the amplitude. So from that, let's see, half the maximum displacement of the particles, wrong. Half the maximum distance apart the particles, wrong. The maximum displacement of the particles from their position at rest, that's correct. The maximum distance apart of the particles, wrong. Okay. Now 24th one. A straight tube is closed at one end and has a loudspeaker positioned at the open end. The frequency of the loudspeaker is initially very low and is increased slowly. A series of loudness maxima are heard. The stationary wave which gives the first maximum has a node at the closed end and an antinode at the open end. The frequency of the loudspeaker is F1 when the first maximum is heard. What is the frequency of the loudspeaker when the fourth maximum is heard? So for the first maximum is a F1. What is the fourth maximum? Actually, you need to know what is the maximum here. For example, you have a pipe, one side open pipe and one side closed pipe. If you produce any wave in front of the open end, if the node forms at the bottom at the closed end, antinode forms at the open end, it gives you a loud sound. That's called first maximum. Okay, and then that if you decrease the frequency of the source, if you increase the frequency of the source, what happens? There are possibilities that you will hear the loud sound second time, third time, fourth time, fifth time, like that. So now here this is the first time loud sound is heard, which is first maximum, and then this is a possible second immediate maximum, which is second maximum. This is the possible immediate maximum, that's third maximum, and then this is a possible immediate maximum, that is a fourth maximum. So for the first maximum, the wavelength is only 1/4 of original wavelength, right? Because you see, the wavelength is longer, and then here 3/4 of the wave is only formed. So the wavelength decreased by 3 times, the frequency should be increased by 3 times. Why? According to the formula, V is equal to F lambda, and then lambda and frequency are inversely related. Okay, here the wavelength, in this case the wavelength is increased. Wavelength is decreased in the second case. So of course the frequency should be increased. That's why how many ever times the wavelength decreased, those many times the frequency increases. So the wavelength is decreased by 3 times here, and then the frequency is 3f1, and then 5 times the frequency is 5. So here the 7th time, how can you say 7th time? This is half, this is 1, this is 1.5, and then this is 1/4. So which is a 7 times of the quarter wave. Okay, that's why the frequency will be 7f1. Okay, and that's why the frequency is 7f1.